Hello. All right, so today we're going to take a look at numbers 90 through 97, although we're skipping 96, in the Unit 8 packet. All right, so let's start on number 90, which is on page 38. Mary bought a pack of candy. The manufacturer claims that 30% of the candies manufactured are red. In her pack, 14 of the 60 candies are red. She ran a simulation of 300 samples, assuming the manufacturer is correct. The results are shown below. Okay, so we could see right here, right? These are the results of our simulation based on the fact that 30% of the candies are red. Okay, so now it says, based on the simulation, determine the middle 95%, I'm just going to underline that, of plausible, which just means maybe possible or reasonable values that the proportion of red candies in a pack is within. Okay, so we know the formula for the middle 95% is just the mean plus and minus 2 standard deviations. And since they give that to us up here, we can just plug these values into our formula. Okay, so now if I take the mean and I first subtract off 2 times this number. Right, so if I take the mean and subtract off 2 standard deviations, that's going to give me 0.185. Okay, now I'm going to take the mean and I'm going to add on 2 times this number. I'm going to do that, I get actually I'll put a 0 in front of that, 417. Okay, so I want to put this through, right? I want to make it an interval. So this right here is the interval that represents the 95% confidence interval, or the middle 95% of values. Okay, the next part says, based on the simulation, is it unusual that Mary's pack had 14 red candies out of the total 60? And they want us to explain. Okay, so let's first figure out what 14 out of 60 is. So if you do that, if you plug that in your calculator, that's equal to, I'm going to say approximately 0.2333, right? So this is the percentage of candies in her pack that was red. All right, now look at this percentage. Does that lie within the 95% confidence interval? Yeah, it sure does. So if it lies within this confidence interval, it's considered a normal, expected, usual occurrence. Okay, so here we have it. I said no, it is not unusual because 14 out of 60, or 0.2333, lies within the 95% confidence interval. And make sure when you give your explanation that you use this terminology. All right, number 91 is multiple choice. So it says, the J&B Candy Company claims that 45% of the candies it produces are blue, 30% are brown, and 25% are yellow. Each bag holds 65 candies. A simulation was run 200 times, each of sample size 65, based on the premise that 45% of the candies are blue. Okay, so I just found 45% of 65 candies, and I got 29.25. So since they say 49% of the candies are blue, somewhere around 29.25 would be blue out of the 65 candies in the bag. Okay, it says the results of the simulation are shown below. So we could see these are the results of the simulation. Okay, this is the mean, which is very close to 45% of 65. So that seems reasonable. And here's the standard deviation. Bonnie purchased a bag of J&B's candy and counted 24 blue candies. What inference can be made regarding a bag of J&B's with only 24 blue candies? Okay, so what I did is, because they give us this, right, let's first find the 95% confidence interval. So I did the mean plus and minus 2 standard deviations, and I found the 95% confidence interval to lie somewhere between 21.398 and 37.142. So anything within this interval is an expected outcome. So since Bonnie purchased a bag and counted 24 blue candies, isn't 24 within the 95% confidence interval? So if that's within the confidence interval, that would be an expected outcome. All right, so if you read through the answer choices, choice 1, the company is not meeting their production standard. Okay, well, that's not true, right? We can't say that that's necessarily true because the bag she received was within the 95% confidence interval. right, so choice 2. Bonnie's bag was a rarity and the company should not be concerned. Okay, so Bonnie's bag is not considered a rarity because 24 is within the confidence interval. All right, choice 3. The company should change their claim to 37% blue candies are produced. Okay, so even though 37% of 65 is approximately 24, which is what Bonnie had, they don't need to change their claim, okay? Bonnie's bag was one bag. Each bag is going to be different. They don't need to change their claim based on this one bag. Their claim is that 45% of the candies are blue, and this is the 95% confidence interval, and 24 is a normal occurrence. It falls within that interval. So if we read choice 4, Bonnie's bag is within the middle 95% of the simulated data supporting the company's claim. This is exactly what they're trying to show here. So choice 4 is our answer. Okay, number 92. Robin flips a coin 100 times. It lands heads up 43 times, and she wonders if the coin is unfair. She runs a computer simulation of 750 samples of 100 fair coin flips. The output of the proportion of heads is shown below. Okay, so just like always, when they give us this mean and the standard deviation, I'm going to use that and do the mean plus and minus, 2 standard deviations, and this right here represents our 95% confidence interval. Okay, so now if we look below, it says, do the results of the simulation provide strong evidence that Robin's coin is unfair? Explain your answer. Okay, so basically, in order for us to say her coin is unfair, the proportion of heads would not fall within this interval. Okay, so she landed on heads 43 times out of 100. Okay, so 43 out of 100 is 0.43. And 0.43 is within this 95% confidence interval, okay? This is within it. So because it's within it, her results are an expected outcome. And since they're an expected outcome, I would not say that that there's strong evidence to support that her coin is unfair. Okay, so you guys can write that out. No, the results of the simulation do not provide evidence that Robin's coin is unfair because 0.43 lies within the 95% confidence interval. Okay, and what that does is that shows us that it is a usual occurrence. Okay, so if you flip to the next page, page 40, both of these two questions, as well as the one on the next page, 41, they're all multiple choice. Okay, so 93, Anne has a coin. She does not know if it is a fair coin. She flipped the coin 100 times and obtained 73 heads and 27 tails. She ran a computer simulation of 200 samples of 100 fair coin flips. The output of the proportion of heads is shown below. Okay, given the results of her coin flips and of her computer simulation, which statement is most accurate? All right, so they give us all of this. I'm going to find the 95% confidence interval and think about her outcome and see if it lies within that interval. Okay, so you could see here that I found the 95% confidence interval. I took the mean and I added on as well as subtracted off 2 standard deviations, and this is the 95% confidence interval. So anything within this 95% confidence interval is an expected outcome. Okay, so anything, I'm going to round these right now, but anything between 40, let's say, heads and 60 heads would be considered a normal outcome. Okay, so if we look back, remember, she had 73 heads and 27 tails. So 73 out of 100 is 0.73. This is not within the 95% confidence interval. It's not even close. It's like way outside the 95% confidence interval. Okay, so this is definitely not an expected outcome. Okay, so honestly, when you look through these answer choices, choice 3, the one that says her coin is not fair, is the best answer there, but they really should have worded it, her coin is most likely not fair, okay? Could this happen? Anything could happen. So you can't say her coin is not fair, but they should have worded this, her coin is most likely not fair. All right, but anyway, that's the best answer choice there, so choice 3 is what we're going with. All right, number 94. The results of simulating tossing a coin 10 times, recording the number of heads, and repeating this 50 times are shown in the graph below. Okay, so that's what we see right here. Based on the results of the simulation, which statement is false? Okay, so let's go through them one by one. 5 heads occurred most often, which is consistent with the theoretical probability of obtaining heads. So if we look here, right, 5, that did occur the most often. And you would expect, right, if you tossed a coin 10 times, it would land on heads half the time and tails half the time. So this is consistent with the theoretical probability. All right, so that's not false. Let's cross that one off. All right, the next one, choice 2. Now, you know what? I'm actually going to look at choice 2 and choice 4 at the same time, because see how they both say middle 95%? So let's take a look at both of those at once. Actually, I'm going to go back to those. Let's start up here. Obtaining 3 heads or fewer occurred 28% of the time. Okay, so let me switch colors for this. We'll go to blue. So here's where 3 heads is. So it says 3 heads or fewer. So if you look at 3 heads or fewer, that encompasses all of these outcomes. So if you count up the number of dots there, you'll see there's a total of 14 dots. So 14 out of, well, altogether, they did this, where is it, 50 times? So 14 out of 50 would be equal to, what is that, 0.28. So actually, this is a true statement as well, right? Obtaining 3 heads or fewer occurred 28% of the time. Yes, it did. All right, so this one's no good. So now if we look at choice 2 and choice 4, remember I said I wanted to look at these together because they both say the middle 95%. Now, although we don't know exactly what the middle 95% is, I'm going to erase this because we're done with choice 3. Although we don't know exactly what the middle 95% is, we do know that there was 50 dots here, right? So why don't we find out what 95% of 50 is? Okay, which is what, 47.5? Which I'm just going to round to 48. So the middle 48 dots here would represent the middle 95% confidence interval. So if there's 50 dots altogether, doesn't that mean that this one dot would be outside the middle 95% confidence interval, and one of these dots would be outside the middle 95% confidence interval? So just to be safe, we could say anything within this right here would be within the middle 95% confidence interval. Okay, so now if we look through the answer choices, let's look at choice 2. It says 8 heads is unusual as it falls outside the middle 95% of the data. Well, here's where 8 falls. That's not outside the middle 95%. That's within it. So this is actually the false statement. This is our answer. And just to look at choice 4, it says 7 heads is not unusual, which means usual. So let's read it as 7 heads is usual as it falls within the middle 95% of the data. And look, 7 is within the middle 95%. So this is also a true statement. So that one's out too. So choice 2 is our answer. Okay, number 95. So this is another multiple choice. This one kind of takes up a lot of room, but it says a game spinner is divided into 6 equally sized regions as shown in the diagram below. So here we go. For Miles to win, the spinner must land on the number 6. After spinning the spinner 10 times and losing all 10 times, Miles complained the spinner is unfair. At home, his dad ran 100 simulations of spinning a spinner 10 times, assuming the probability of winning each spin is 1/6. The output of the simulation is shown in the diagram below. All right, let me move this up because this question is taking a lot of room. Okay, which explanation is appropriate for Miles and his dad to make? All right, so let's just go through them one by one. It says choice 1, the spinner was likely unfair since the number 6 failed to occur in about 20% of the simulations. Okay, so the number 6 failed to occur. That means there was 0 6s. So here we see 0 6s. Well, 0 6s actually occurred, look at that, a bunch of times. It looks like it occurred a little bit under 20% of the time. So the spinner was likely unfair since the number 6 failed to occur in about 20% of the simulations. Well, that would make it most likely fair, not unfair, right? Because that would be an expected outcome. That would be something that we call usual. Okay, so I just want to point this out again. When we look right here, right here, no 6s, so 0 6s, occurred in about 20% of the simulations. So we can say that this is an expected outcome, okay? It is a usual occurrence. Therefore, the spinner is most likely fair, okay? So we can see that right here. Okay, so you can read through each of the answer choices. We already said choice 1 was out, but if you come over here to choice 3, the spinner was likely not unfair. That's like a double negative, right? Not unfair. I'm going to actually, another way to say that is fair. So the spinner was likely fair since the number 6 failed to occur in about 20% of the simulations. That's so true. Okay, the number 6, there was 0 6s. It failed to occur in about 20% of the simulations. So choice 3 is our answer. Okay, finally, if you flip to the next page, page 42, we are going to skip over 96 and we're going to take a look at number 97. So Mrs. Jones had hundreds of jelly beans in a bag that contained equal numbers of 6 different flavors. Her students randomly selected 4 jelly beans and they were all black licorice. Her student complained and said, "What are the odds that I got all of that kind?" Mrs. Jones replied, simulate rolling a die 250 times and tell me if 4 black licorice jelly beans is unusual. Explain how this simulation could be used to solve the problem. Okay, so basically she wants them to use a simulation of rolling a die and apply it to how that could be used to explain whether or not it would be considered unusual to reach into this bag and select 4 black licorice jelly beans. All right, so hit pause, try it out, see what you think, and then we'll talk about it. Okay, so this is what I was thinking. Okay, since there are 6 sides to a die and 6 flavors of jelly beans, the student could assign a number to each flavor. The student could then see how many times the number that corresponds to the black licorice occurred 4 times in a row after 250 simulations of rolling a die. Okay, so instead of actually doing, like reaching into the bag and grabbing 4 jelly beans 250 times, they could just run a simulation using, a die, since the number of sides of a die matches up with the number of flavors of jelly beans in the bag. So it's just a lot faster way to do the same thing.